Okay, in this question, we are going to investigate compactness. Okay, so let's look at the part A of the question. Compactness, alright, C is defined by 4a over pi d squared. Okay, so whenever you see an unfamiliar definition, please take note of what the different parts of the equation mean. So here, you are told in the question, A refers to the area, alright, D refers to the maximum distance between any 2 points in a region. So part A now, verify that C is equals to 1 for a circular region. So what I can do is I can actually visually see, okay, the circle, okay, and figure out what is the compactness of this circle. Okay, so let's see, C is equals to 4 times the area over pi times the maximum distance between any 2 points in the region square. Alright, so now what's the area of the circle? Well, if the area, okay, if this circle has a radius r, then the area is pi r squared. Okay, the maximum distance between any 2 points will be its diameter. Okay, so that's going to be 2r and then square. Okay, the diameter square. Okay, the diameter is 2r. Okay, the area is pi r squared. Alright, so if you work this out, you get 4 pi r squared over 4 pi r squared, which really equals to 1, okay, as required. Okay, so this is a good thing because it means that whatever that you are actually doing, okay, actually you're on the right track, okay, and that's what this part A is meant to do. Okay, part B now. Consider a rectangle whose lengths are in the ratio x is to 1. Okay, so let's draw a picture. Okay, a picture always tells 1,000 words. So if the ratio is in x is to 1, then well, the longer side must be x and the shorter side must be 1. Okay. Part B, show that the compactness C is 4x over pi times 1 plus x squared. Okay, so let's once again use the definition 4a over pi d squared. Okay, and let's think about it now. What's the area of this rectangle? Okay, the rectangle has area pi, no, not pi, 1 times x. Okay, the area of this rectangle is 1 times x. Okay, so the area is x, well, times 1. Now how about the distance? Okay, the distance between any 2 points, the maximum distance, will be the length of the hypotenuse, okay, the diagonal. Okay, and this length is root of 1 plus x squared. Okay, because, well, this is right angle, alright, so it's actually a right angle triangle. Okay, over here, alright, this is a right angle triangle. Okay, here. So the b is root of 1 plus x squared, okay, and then we square it for the formula. Alright, so this becomes 4x over pi times 1 plus x squared. Right, which is shown, okay, as required. Okay, part C now. Show that dc dx is as shown. Now, in this question, we basically needed to differentiate the expression that we have found above. Okay, so let's just do that differentiation by quotient rule. Okay, that's v, okay, du dx minus u, right, minus u 4x times dv dx 2 pi x over pi times 1 plus x squared, okay, v squared. Alright, and if you were to reduce this, okay, you really do get 4 times 1 minus x squared over pi times 1 plus x squared. Okay, I do want to point out though that this part C is actually 3 marks, okay, because, well, even if you didn't know how to do part B, you could have just taken the expression in B and differentiated it to get these 2 marks, okay? Now, free, of course, provided you know how to do differentiation, right? So if you're not sure how to do differentiation, please go and revise and learn that part, okay, of the syllabus, all right? Okay, so this is an example of a question where you can get back into, okay, even if you were stuck on B, okay? If you are stuck on B, all right, if you are actually stuck on B, please don't give up, okay? Just move on to part C, okay, so that you can hit back into the question and use that. Now, even if you were stuck on part C, you can also do part D, okay? D says, hence find the value of x which gives the maximum compactness. So for maximum compactness, okay, we know that dc dx must be equal to 0. Okay, and you are given the answer that you need to work towards. Okay, so even if you got, like don't know how to do dc dx, or even if you got the answer for dc dx wrong, alright, you can still do this part. Alright, so dc dx being 4 times 1 minus x squared over pi times 1 plus x squared squared, okay, would mean that the numerator 4 times 1 minus x squared must be 0. Okay, and so therefore x is plus minus 1. Alright, they want the max a value of x, so x being the length of a rectangle, okay, means that it has to be positive, so therefore x is equals to 1, alright, since, well, x has to be positive, okay, and this is kind of the only answer that you need, so therefore this gives the maximum, right, compactness. Okay, now, so what does this mean? Okay, part 2, identify the geometrical significance of the results. Okay, so earlier we drew a rectangle, okay, whose ratio was 1:x. But now if x was also 1, you can see that the figure, okay, the most compact rectangle, alright, is actually a square, okay, because the ratio is actually 1:1. Okay, they have the same length. Okay, part E now. Consider an equilateral triangle, okay, of side length x units. Okay, so let's draw a triangle. Each side has length x units. Alright, as such, find an expression for the area of this equilateral triangle. So we can see that this angle here has to be pi over 3. Okay, and so using trigonometry knowledge, we know that the area is equals to half times sum product of the two sides times sine of the angle inclusive. Okay, half AB sine C. So this is half x squared times root 3 over 2, okay, which is root 3x squared over 4. Right, if you're not sure how to do this, please go and revise that part of the syllabus. Okay, the area of a triangle. Part F, hence find the exact value of C for an equilateral triangle. The formula for C, right? So C, let's revise, it's 4a over pi d squared. Okay, we have A already, so now we need D. Okay, so if you look at this figure, okay, what is the maximum distance between any 2 points? Okay, so, well, because this is equilateral triangle, the maximum D is actually x, because that's when I take 2 points along the boundary and I join them up together. Okay, this length is shorter. This is shorter than x. Okay, and if you try your best to find a longer length, it doesn't work. Alright, so D is actually equals to x. So the compactness is 4 times root 3 over 4x squared over pi times D, which is x squared. Okay, so this is root 3 x squared over pi x squared. So that's root 3 over pi. Alright, so this question is building up to something, okay, quite clearly. Okay, let's look at the next part. Consider a regular polygon of n sides now, constructed such that its vertices lie on the circumference of a circle of radius r units. Alright, so we have some polygon. Okay, I don't know how many sides my polygon has, okay, it's just n. Okay, so I do know that it starts off at the center. So what I'm going to do is I'm going to draw a kind of a picture like this. Okay, so like this, okay, like this, okay, and then there will be more sides. Okay, so this is an n gun. Okay, and all the sides have equal length. Okay, my drawing is not very good, but this is roughly how it's drawn. Now I do know that the interior angle, okay, the angle at the center must all be 2 pi over n. Alright, overall. Okay, the angle at the center must be 2 pi over n. So let's look at the question now. G. If n is more than 2, okay, so you have at least 3 sides and it's even, okay, then show that C is actually equals to as such. Okay, so let's use the formula. C is 4a over pi d squared. Okay, so let's find what A is first. Okay, so let's see. To find A, I have a picture like this. Okay, and I can see that, well, I can actually divide the n-gun into n equal triangles. Okay, now it doesn't look equal, but all of these triangles actually have equal area. Okay, because this center, okay, was split into n equal angles. Okay, and if all of these sides are equal, okay, and all the radius, okay, are the same because it's all lying on a circle, then each triangle must be congruent, right, to each other. Okay, so each little rectangle, triangle, okay, each triangle, all right, has area, okay, half times the radius, okay. Well, the radius is r, okay, and the other r square rather, okay, because I have two sides, times sine of the interior angle, 2 pi over n. Okay, basically each little strip looks like this. Okay, this angle is 2 pi over n, right over here. Alright, so the total area must be n times of this. Okay, it's half r square sine 2 pi over n, then times n. Okay, and that's the total area of the polygon. Okay, so now we are going to look at the maximum distance between any 2 points, okay, in this polygon. Okay, so if you think about it, actually that will be the diameter of this circle that is actually enclosing it. Okay, so now if you can't visualize that, what we can do is we can start with smaller numbers. So let's say n is 4. Okay, so n being 4 will mean that you have a square, right? Okay, you have a square, and pardon my art, but the picture would look something like this. Okay, so the shortest distance, the maximum distance rather, between any 2 points, okay, would be the diagonal of the square, okay, which is actually the radius of this circle. Alright, so let's try another case. Let's say n is 6. Okay, so let me draw my circle first. So now I have a hexagon inside here. So 1, 2, 3, 4, 5, 6. Okay, and the maximum distance between any 2 points would be something like this, or maybe like this, or like this, either one of them. Okay, and they are all the diameter of the circle. Alright, let's do another one. Let's say n equals to 8. Okay, so we have an octagon now. So this will be 1. Okay, so for this case, d will be 2r, actually, the diameter. Okay, because if you think about it, for any even integer, okay, the distance between 2 points will be the diameter. So overall, c will be 4a, which is n over 2r square, sine of 2 pi over n, over pi times d square, which is 2r square. Okay, and well, what we need to hope for is that this thus gives us the answer of c equals to n over 2 pi times sine 2 pi over n. Okay, and let's check if it does. This is 2nr square sine 2 pi over n. The bottom is 4r square pi. Okay, and what do we get? We get n over 2 pi sine 2 pi over n. Right, so we are on the right track. Okay, and that's good. Alright, so over here, let me make a comment. Okay, if you are not sure about an overall picture of how it looks like for a general n-gun, alright, one good strategy is to actually start with a smaller, okay, case. If you're not sure, okay, how the big case looks like, what we can do is we can start with a smaller case and then hopefully spot a pattern, okay, that you can arrive at. Now, of course, we are not asked to prove that this is true. Okay, to prove that this is true, you would probably need to use induction, okay, which is not going to be so easy. All right. Okay. However, in this case, you are not needed to do that. Okay. In fact, you are given a result, okay, that you need to work towards. So another confirmation that you have is that when you actually get this, see, we got this, we got the result that, okay, is in the question. Okay, so since we got the result that's in the question, it makes my initial hypothesis more believable. Okay, even though I didn't actually give an exact proof for it. Okay, so if you are in this kind of situation, one way to do it is to start off with smaller cases that hopefully can build up into some more general cases. Okay, start with a specific case and generalize it to a higher order case. Alright, H. Illustrate with the aid of a diagram that D is not equals to 2R when N is odd. Okay, so here in another way we can see it is that we need to give a counter example to this idea, that when N is whatever number, D is always 2R. That's not necessarily true. Okay, it is only true when N is even. Okay, if N is odd, that is not necessarily 2R. Okay, and the easiest case that I'm going to use is N equals to 3. Okay, so when looking for counter examples, start small. Okay, start simple, so that we can actually get an answer, easy answer. Alright, and in fact, if you look at N equals to 3, that is the same as looking at a triangle, equilateral triangle. Okay, and we should draw the circle also. Wait, not a very good picture, but you can see that the diameter of this circle, is over here. Alright, and it is definitely not the shortest distance between any 2 points. Okay, in fact, we can also see this from part E from part E of the question. Okay, the shortest distance, the maximum distance between 2 points, is not the diameter 2R. Okay, in fact, it is equals to the side. Alright, so therefore D is not equals to 2R. Okay, for any odd integer. Okay, so next part. So we are going to now figure out what is the regular polygon with the least number of sides for which the compactness is more than n equals to 0.995. Okay, the question does tell you that if n is odd, the question says if n is odd, they give you the formula for C. N times sine 2 pi over n over pi times 1 plus cosine pi over n. Alright, so we basically need to split this up into two cases. Okay, we're going to split this up into two cases. So case number 1, alright, case 1, when n is even, what happens? So if n is even, let's use the formula for an even n. N over 2 pi sine 2 pi over n is more than 0.995. Right, so I'm going to switch over to the GDC now to continue. Okay, so what we're going to do is we're going to the graph page. Okay, we're going to key in x over 2 pi times sine of 2 pi over n, or x. Alright, press enter. Please make sure that your mode is in radian mode, as you can see from up here. So we can see the graph here, but we want to solve this to be more than 0.995. So I'm going to use the split screen table, and look for the value of n, the compactness is more than 0.995. So you can see here, I've come down to 36. 37 seems to work, but remember here n must be an even number. So even though here there is a value of n being 37, it actually doesn't satisfy your answer. So we need to skip 37 and choose 38 actually as the answer. Alright, so now when n equals to 36, using GDC, n over 2 pi sine of 2 pi over n is actually 0.9949. When n equals to 38 rather, n over 2 pi times sine of 2 pi over n is actually equals to 0.99954. right? 9954. So therefore the minimum value of n is 38. Right, that's for n is even. Now, what about if n is odd? Okay, so let's do that using a similar method. Okay, we need to solve n sine 2 pi over n pi rather times 1 plus cosine pi over n is more than 0.995. Okay, similarly for n being odd, so let's sketch the graph. X sine, x times sine of 2 pi over n, sine of 2 pi over n, or x rather, okay, divided by pi times 1 plus cosine pi over n. Cosine of pi over n. Okay, get this, and then you go to table, split screen table. Okay, and then you look for the value of n where the compactness rather is more than 0.995. Okay, so here, yes, 29, right, is 1. Okay, 28 isn't yet, 27 is. Okay, so but we need to skip 28, so we're going to give 27 and 29 as our answers. Okay, so using GDC, right, when n equals to, now you can observe 27, alright, n sine 2 pi over n over pi times 1 plus cosine pi over n is 0.9943. When n equals to 29, okay, n sine 2 pi over n over 1 plus cosine pi over n is 0.9951. So in this case, the minimum value of n is 29. Okay, so as you can see, the minimum value of n overall is 29. Okay, so the overall answer, right? Overall answer, a regular 29-sided polygon has, okay, C compactness 0.995. So therefore, that's the least value of n. Right. J part 1. For n being even, use L'Hopital's rule to show that the limit of n tends to infinity of C is equals to 1. Okay, so once again, even if you couldn't do the last two parts, you could still do this because you are able to read the question, right? So even values of n, alright, that means that the compactness is going to be n over 2 pi times sine of 2 pi over n. Okay, that's what is given in G, right? So even if you didn't know how to do the last two parts, you can come back into the question. Okay, so limit as n tends to infinity of C will be the limit as n tends to infinity of n over 2 pi sine 2 pi over n. Okay, and we need to use L'Hopital's rule. Alright, now, so L'Hopital's rule, if you remember, okay, is one where we have limit of something, okay, tending to some zero, I think, okay, some angle or somewhat, okay, of some 0 over 0 indeterminate form, okay, or it could also, of course, right, be infinity over infinity, okay, kind of form. Okay, so looking at this, we need to know that we need to rearrange this lah. All right, somehow. Okay, so what I'm going to do is I'm going to observe that this expression, right, can be written as 2 pi over n over 2 pi over n. All right. Okay. Sine of 2 pi over n over sine of 2 pi over n. All right. Okay. And if you look at this carefully, this is actually of a 0 over 0 form, because as n tends to infinity, 2 pi over n tends to 0. Okay, so sine of 2 pi over n, okay, being continuous also tends to 0. So now we can use L'Hopital's rule on this. This is the limit as n tends to infinity of minus 2 pi over n squared. Okay, cosine of 2 pi over n divided by minus 2 pi over n squared. Okay, which is the same as the limit as n tends to infinity of cosine 2 pi over n, right? Which is going to be the limit now as n tends to infinity, which is equals to 1 overall. Okay, so this is using L'Hopital's rule, right, to find this answer. Using your answer for part 1, okay, show that limit as n tends to infinity of c equals to 1 for n being more than 1 and n being odd. Okay, so now let's figure out what is the formula when n is odd. Alright, c is actually n sine of 2 pi over n over pi times 1 plus cosine pi over n. Alright, not so easy to use, but we are given a hint that we can use the answer for part C, okay, for part 1. So anyway, let's do it. Alright, so let's consider this, okay, and let's see what we can do. So this, just copying down the question, gives me n times sine 2 pi over n over pi times 1 plus cosine pi over n. Okay, so now I need to find a way to bring in the answer, okay, for the part 1. Okay, so from part 1, I know that the limit as n tends to infinity of n over 2 pi, okay, times sine of 2 pi over n, right, is equals to 1. So I kind of see it, alright, here, as you can see, there's a n over n times sine 2 pi over n. There's also a pi, but there's just lacking a 2 lah. Okay, so if only I can bring a 2 in, then I can just, make use of some manipulation, right, to change my expression. Okay, and that's what I'm going to do. So I'm going to rewrite this, okay. I'm going to put n over 2 pi, okay, really naively. Okay, so I'm just going to force it to come out. Okay, now, but I can't just write this, right? I'm going to keep my expression the same. So this is going to be multiplied to 2 over 1 plus cosine pi over n. Alright. Okay, so here, this is the answer in part 1, and this is some unknown lah. So hopefully, let's just make a comment here. Hopefully, okay, this limit exists, okay? Because if it does, then I'm able to split up the limits, okay? If it doesn't, then I'm in trouble because I can't just randomly split up limits, okay, like this. But hopefully this limit exists, okay? Now let's just evaluate it by itself, okay? What's this limit on its own? Okay, this is actually equals to limit as n tends to infinity. Okay, so let's just evaluate it. So this becomes 2 over 1 plus cosine of 0, because as n tends to infinity, pi over n, alright, tends to 0, right? Okay, as n tends to infinity. So, it exists because this is 2 over 1 plus 1, which is 1. Okay, so it does exist. Okay, so it does exist. So here, I can actually split up this limit. So this is limit as n tends to infinity of n over 2 pi times sine of 2 pi over n. Then this thing times the limit as n tends to infinity of 2 over 1 plus cosine pi over n. Right, this is because both limits exist. Okay, and then now we can just evaluate them separately. So this is equals to 1 as found in part 1 times 1 as we've just found. Okay, so this is 1 overall. Alright, part 3. Interpret geometrically. okay, the significance of parts 1 and 2. Okay, so let's see, as n tends to infinity, we know that in either case, the limit, okay, of the compactness in either case is always 1, okay, be it, alright, n is even or n is odd, okay, be it n even or n odd. Now we have found in part 1, or rather part A earlier, we know that the limit, okay, the compactness of a circle, okay, is actually 1. Okay, so therefore we can tell that as n increases, okay, meaning you get more and more sides, okay, any regular polygon, okay, right, will have compactness, okay, approaching a circle. Approaching that of a circle. Which kind of squares with the physical idea, alright? You know, if you take a general regular polygon and you increase the number of sides, it will look and approach a circle. Okay, and this particular investigation helps us to see that really, okay, it really does physically, mathematically approach that of a circle as well. Okay, so I hope you found this video helpful and you've picked up some important skills, okay, in handling investigative questions. I'll see you in the next one.